Welcome back to today's session. In the previous session, out of the IBFS methods, we learned the first method of computing IBFS, which was Northwest Corner Rule. The second method that we would be learning today is called Least Cost Method or LCM. This method is also called Matrix Minima Method, right? It is also called matrix minima method. So how does this method work? That we will be learning based on the steps, right? So the first step, step one, is determine the smallest cost in the cost matrix of the transportation table. See, out of the cost matrix given, identify the minimum most cost or the smallest cost. Let me assume it was Cij, that is the cost between ith source and jth destination. Okay, in that case, make an allocation there. How much allocation has to be done? Allocate Xij is equal to min of Ai comma Bj out of the supplies and the demands, whichever is the minimum, that will become the assignment or the allocation or the transportation number of units in the cell ij. Okay, this is the first step. Second step, see, once you have done the allocation for xij, if xij is equal to ai, if your minimum was the supply, then cross off the ith row and decrease the jth column by ai, right? That row will get removed, and in the column the demand value has to be adjusted by subtracting how much ever you have satisfied. Then we'll go to step 3. If at all it was not the supply which was minimum, if it was the demand which was minimum, then what has to be done? If xij is equal to bj, cross off the jth column, the column has to be crossed off in the transportation table, and decrease the supply by the amount that you have transported. Then go to step 3. If at all supply and demand both were equal, what to do? In some in between row, in some in between step, the row and the column, that is the supply and the demand, both were equal. If xij is equal to ai and is equal to bj, cross off either the ith row or the jth column, and don't cross off both. Okay, but you should not cross off both, but only in the last step you will have the supply equal to demand for the last cell allocation, right? In that case you can cross off both row and the column. Okay, the step 3 says repeat step 1 and step 2 for the resulting reduced transportation table until all the supply and the demand requirements are satisfied. One additional important note here: whenever the minimum cost is not unique, that means to say you don't have a single minimum value, the minimum value is present in 2 places or 3 places, what to do? Make an arbitrary choice out of those 3 values, whichever you want you can just select. Okay, make an arbitrary choice among the minima. This is the overall procedure of least cost method. Hope you have understood. Even if you have not understood, when we are solving the problem, it will be very easy for you to understand. This is one of the most simplest methods for IBFS. Okay, let us have a look at the problem. So I'll be taking the same problem, whatever we have solved, using northwest corner rule, so that it will be helpful for you to compare the answers, right? And one more thing that I want to tell you is all the methods will not give you the same answer. IBFS can vary. The optimal solution will be the same. The initial basic feasible solutions need not be the same. If at all you have got an answer of some, let me say 120 or 128 or something using northwest corner rule, there is no compulsion that you are supposed to get the same value when you solve it using least cost method. That is why I have taken the same problem to show you that you can have different values. Okay. Obtain the IBFS of the transportation problem whose cost matrix is given below. Okay, the cost matrix is 274, 331, 547, 162, and the demands are 7, 9, 18, and the supplies are 5, 8, 7, 14. When you add up these two, you will get 34. Therefore, it is a balanced problem. Only if it is a balanced problem and minimization case, you are going forward. Okay. Summation A is equal to summation Bj, which is equal to 34. Therefore, it is a balanced transportation problem. Now I am supposed to solve it. See, whatever is there in white here, this is your cost matrix. Identify the least cost. See, here you have one, and here also you have one. Both are minimum costs. You can either select this or select this. But I go with a certain logic of selection. See, this is not given in the book. The book says arbitrarily you can select anything. But this is Bhaskar's method, Bhaskar's choice. So how I select is look at this one and see how much you can satisfy. See, here the demand is 18, supply is 8. So you can transport 8 units. If at all I come here, supply is 14, demand is 7. So you can transport 7 units. So out of the two places where you can transport more, here, right? So I will select this. Okay, I will select this one. So here I can transport 8. 8 minus 8 becomes 0. Here 18 minus 8 becomes 10. So I made an allocation at 2, 3. At cell 2, comma 3, I made an allocation of 8 units. At 2, 3, I have made an allocation of 8 units. So what happened? 1 minute, I'll just select the color. Okay. This column, sorry, this row got crossed off because it became 0. This row is no more there. So what next? The remaining cost matrix is 274, 547, 162, which is the minimum cost, 1. So how much you can transport? Supply is 14, demand is 7. 7 you can transport. So you make an allocation at 4, comma 1 with 7 units. At 4, comma 1 with 7 units. So this row was already gone. Now this column is gone. What is the remaining matrix? 7, 4, 4, 7, 6, 2. Out of this, which is the minimum cost? Correct. 2. So here you are supposed to make an assignment. How much you will make? Supply is 7. Demand is 10. So which is minimum? 7. So you can make an allocation of 7 here. Okay. 7 minus 7 becomes 0. 10 minus 7 becomes 3. So you made an allocation at 4, comma 3 with 7 units. 4 comma 3, 7 units. So this row was already gone. This column was already gone. Now this row also went. Now what is the remaining cost matrix? 7, 4, 4, 7. So 4 is the minimum on both sides. So if at all I satisfy here, supply is 7, demand is 9. I can transport 7. If at all I am transporting here, supply is 5, demand is 3. How much I can transport? 3. So Bhaskar's logic says put allocation in this cell. So I make an allocation 7 here. So 7 minus 7 becomes 0. 9 minus 7 becomes 2. Fine. So I am making an allocation at 3 comma 2 with 7 units. 3 comma 2, 7 units. So this row was already gone. This row was also gone. This column was gone. Right? Now this row also went off. What is the remaining cost matrix? 7 and 4. So which is the minimum cost? 4. So how much allocation you can make? 5 is the supply, 3 is the demand. 3 you can satisfy. So 3 minus 3 becomes 0 here. 5 minus 3 becomes 2 here. So this column will go off. So you are making an allocation at 1 comma 3 with 3. At 1 comma 3 with 3 units. So this row went, this row went, this row also went, this column gone, this column also gone. What is the cost left? Only cost matrix left is 7. So this is the last cell. So whenever you come to the last cell, what will be the situation? Your supply will be equal to the demand. Your supply is 2. What is the demand? 2. So you can satisfy 2. So this row also goes and this column also goes. So now your problem is solved. Now you made an allocation at 1 comma 2 with 2. Okay, 1 comma 2 with 2. Now calculate the total transportation cost. 2 into 7 plus 3 into 4 plus 8 into 1 plus 7 into 4 plus 7 into 1 plus 7 into 2. So 2 sevens are 14, 3 fours are 12, 8 ones are 8, 7 fours are 28, 7 ones are 7, 7 twos are 14. So I add 14 plus 12, which will be 26. 26 plus 8, 34. 34 plus 28, 4, 62. 62 plus 7, 69. 69 plus 14. 69 plus 10 is 79. 79 plus 4 is 83. So my total transportation cost is 83 rupees. Same problem I had solved using northwest corner rule. What was the answer? I had got 102 rupees. Now I got 83 rupees. So in this problem, least cost method is giving us better solution of 102 rupees. Let me take the second problem and solve it using least cost. So this was the problem considered. So before starting itself, make a note of what was the answer in the previous method. 128 was the answer. Okay. Northwest corner rule, I got 128 rupees. Now let us try to solve the same problem using least cost method. Cost matrix is 6415, 8927, 4362. Supplies are 14, 16, 5. Demands are 6, 10, 15, 4. 10 plus 6, 16, 16 plus 15, 31, 31 plus 4, 35. Here 16 plus 14, 30, 30 plus 5, 35. So balanced transportation problem. So out of the entire cost matrix, which is the minimum cost? 1. So I need to make an allocation here. How much? Supply is 14, demand is 15. Minimum is 14. So I can transport 14 units at 1 comma 3. So I make an allocation at 1 comma 3 with 14. So supply 14 minus 14 becomes 0. Demand 15 minus 14 becomes 1. Okay. So at 1 comma 3, 14 has been made. So this row got removed. Now what is the remaining cost matrix? 8, 9, 2, 7, 4, 3, 6, 2. So I have 2 here and I have 2 here. Where to satisfy? Just check. If at all I satisfy here, demand is 1, supply is 16. So I can satisfy only 1. Here, if at all I'm making an allocation, supply is 5, demand is 4, I can transport 4 units. So Bhaskar's logic says this is better. So I make an allocation here. So at 3 comma 4, I make an allocation of 4 units. So what happens to the supply? 5 minus 4 is equal to, sorry, typing mistake. 5 minus 4 is 1 and 4 minus 4 is 0. And this column gets cancelled. Okay. So this row went already. Now this column went. What is the next remaining cost matrix? 892, 436. So obviously minimum cost is or least cost is 2. So I'm supposed to satisfy here. Supply is 16 and demand is 1. So 1 minus 1 becomes 0. 16 minus 1 becomes 15. And at 2 comma 3, I make an allocation of 1 unit. So this column will get crossed off now. So 2 comma 3, I am transporting 1 unit. So this row went off. This column went and this column also went. Now what is the remaining cost matrix? 8943. So which is the least cost? Obviously 3. How much you can transport? Supply is 1, demand is 10. So I can transport only 1. So transport 1 at 3 comma 2. So what happens? Supply becomes 1 minus 1 0. Here demand is 10 minus 1 9. So this row gets cancelled off. Okay. At 3 comma 2, 1 unit has been transported. So this row went. Next this row went. This column has gone and this column is gone. What is the remaining cost matrix? 8 and 9. So which is the least cost? 8. So I am supposed to transport at 8. So how much you can transport? Supply is 15. Demand is 6. Minimum is 6. So you can transport 6 units here. 6 minus 6 becomes 0. 15 minus 6 becomes 9. This column gets crossed off. So at 2 comma 1, you are making an allocation of 6 units. So this row went. This row also went. This column is gone. This column is gone. And this column is gone. What are you left out with? Only one cost. Only one cell with cost 9. So how much you are supposed to transport? Supply is 9. Demand is 9. See, because this is last cell, whenever you come to the last cell, your supply and your demand will match if you have solved it correctly. So supply is matching with the demand. So both row and column gets cancelled. 9 units are transported. So at 2 comma 2, I am transporting 9 units. So now we are supposed to compute the transportation cost. So 14 into 1 plus 6 into 8 plus 9 into 9 plus 1 into 2 plus 1 into 3 plus 4 into 2. So 14 ones are 14, 6 eights are 48, 9 nines are 81, 1 twos are 2, 1 threes are 3, 4 twos are 8. So I get 14 plus 48 plus 81 plus 2 plus 3 plus 8. The sum will be 156. See, in this problem, if you have a look, northwest corner rule, the IBFS or the total transportation cost for IBFS was 128 rupees. I try to solve the same problem using least cost method. I am getting 156 rupees. See, when you compare to the first problem, least cost method was better than NWCR. When you compare to the second problem, NWCR is better than LCM, right? So any doubt with LCM method? If at all you have any doubts, you can kindly post it onto the classroom platform. Hope you have understood. So shall we wind up the class for today? Fine. Thank you. Thank you for your patient listening. Kindly stay home, stay safe, have a nice time, enjoy.